Hello everyone, I am Oshwara. Today we are discussing about class 11 physics chapter number 4 motion in a straight motion in a plane. Okay, so in this chapter we will discussing about that the first of all motion in a plane. So in a motion in a plane there are the main four things are there: vector addition, then after velocity, then after accelerations, and also then after projectile motions. So first of all the graphical additions and the subtraction of vector. But first of all, the what is a vector? A vector is quantity that has a both magnitude and directions. Position in an example of the vector quantity. Okay, the vector is a quality that has both magnitude and the directions. So position an example of a vector quantity. Now a scalar quantity with no directions, the mass of object is an example for a scalar quantities are there. Now see here the notation of vectors. The vector it is represented as the dark bold f or the f raised to vectors are there, and the magnitude of vector it is represented by the bright f or a magnitude of f or a magnitude of f vectors. So the direction of vector might be 35 degrees south of east and 25 degree above the, so plus x axis or minus. So scalar m not bold face or no arrow on that vectors. Now see here the graphical additions of vectors we will discussing in the previous lectures. Okay, in but I explained this lectures due to the these slides. So see here this is very easy to these factors, the graphical addition of vectors. See here that to add the vectors graphically they must be placed tip to tail. See this is our tip and this is our tail. See here this is our tip and this is our tail. So due to the tip to tail additions are there, the resultant vectors is f1 plus f2 point from the tail to the first vector and tip of the second vector. So this is sometimes called the resultant vector r. See this is our resultant vector r, this is our tip and this is our tail. See here it is put like that, then after we will get the also resultant vector r. So this is our addition of f1 and f2. Now see here the vector simulations are there. See here there are the r is 26.4, theta is over 65.4, rx it is equals to 11, ry is equals to 24. So we will get that the answer of that. So see vector simulations are there. Okay, now see here the example is that string table vector component unit vectors are there. Now types of vectors are there. First of all, types of vectors are there. It means types of vector. It has a displacement vector. Okay, we will discussing about that in the last lectures are there. Position and the displacement. We will discussing in the next lecture. Position vector and the displacement vector. So displacement vector. See here there are the two points are there, A and the second point is B. So we are discussing about point A and point B on the time what will happen. See here what will happen. So whenever the this is the positions are there, this is the two different positions are initial position and final position. So difference between the initial position and final position it is known as the displacement vector. So this is known as the displacement vector. So it is goes from one in this point to this point. So this is our displacement vectors. So now here displacement vectors are there. How it will be all the displacement vectors? See the three different path it will be goes like look like this from this point to this point, then after it will be going look like this, and also it like this look like as. So there are the three different path 1, path 2 and path 3, but we are just difference taking the difference between the initial point and final positions. On that time it will be used that the two vectors are there, and it is represented as the displacement vectors. There are the very small value of that it is a difference of that path length and the displacement. Okay, so this is known as the displacement vector due to the, so because of that there are we are not considering that the how much values of the path length, but we are just considering that the initial positions and the final positions are there. Okay, so this is known as the displacement vectors. Now then after we are discussing about the parallel vectors. Okay, parallel vectors it means there are the, see here there are the both has a same directions are there. The magnitude is different but the same value direction is the same. So this is this equations is this vector is known as the parallel vector. Now see here anti-parallel vectors are there. So anti-parallel vector it is represented as and directions will be changed. Magnitude is, doesn't matter, but direction, it is in the opposite direction. This is in this direction, it is in opposite direction of that. So this is our known as that the anti-parallel vectors. Now see here, the relative displacement vectors are there. See, first of all, what is the relative displacement of vector? See, it will be starting from this point to this point. It will be relative. See here, it will be path length is this point to this point. First of all, it will be reached at the p1 to p2, and then after it will be reached at the p2 to p3. So there are the two vectors are there, p1 and p2. So first of all, what we need to do, what we need to do, so see here, the vector, this relative displacement vectors are there. See, it is starting from, so it is our p1 and p2 vector a, it is p1 p3, it is vector c. So we will get that the addition vector is that, if we get that the addition of vector a and b, we will get that the vector c. And also a vector a vector c, it is equals to, it is a additions vector c, it is equals to a vector a plus vector b, and the vector subtraction, it is equals to c vector c. So this a will be minus from this value, so we will get that the vector subtraction is that c minus a vectors, c minus a vector. So we will get, also we will get that the b vector. So this is relative displacement vector of point p3 and relative to p2. So this is known as the relative displacement vector. So now vector addition via parallelogram. So in this phenomena, what we will do, see here, we have a vector is b vectors are there, vector b. Now vector addition via parallelogram, it means, see here, there are the two vectors are there, vector b and also vector a. So on that time, what we will do, see here, this is the vector e, we will drawing the another vectors parallel vector to the vector b at the positions of vector a. See here, also parallel, draw the parallel vector at the b as same as the here, and we will get that the vector of ab to parallel vector at here. So we will get that the a plus b, it is equals to b plus a. So see here, we will get that the result vector, this is the parallelogram. So this resultant vector is vector c. So this is our additions of that the vector addition via parallelogram. Now it's a graphical method of the vector additions are there. See here, there are the graphical method. See, this is our vector b, this is our vector a. So on the time, what will we will get the on the time, okay, these are our graphical notations, and due to this graphical notation, we will get that the value of that, we are drawing that the values, and due to the value, due to the construction, during the construction, and draw the graphical values. So we will get that the resultant vectors c. Okay, so see here, this is our graphical method to vector additions. Now see here, the graphical subtraction of a vector. Think of a vector subtraction a minus b as a plus minus b, where the vector minus b is same magnitude as b but point in the opposite directions. It means that value shift direction in the opposite direction. So there are the minus b. So vector may be removed any way you please to place them to tip to tail, provided that you do not change their length or nor rotate them. So see here, vector component here, it is a theta, and ax, it is equals to, our ax, it is equals to a cos theta, and ay, it is equals to a sin theta. Due to this, see here, we are applying the Kirchhoff, sorry, here we are applying the Pythagoras law. So ay, it is equals to, so ay, it is our adjacent, this is our opposite, this is our opposite sides, and this is our adjacent side, this is our hypotenuse. So due to the sin theta is equals to, sin theta is equals to hypotenuse, sin theta is equals to hypotenuse upon adjacent, sorry, hypotenuse upon opposite angle divided by the opposite angle divided by the hypotenuse. So we will get that the our opposite angle is ay, and hypotenuse is a. So we will get that the sin theta is ay, it is equals to a into sin theta. Due to this phenomena, also there are the adjacent upon adjacent upon hypotenuse. So we will get that the ax, it is equals to a cos theta. So this is our vector component are there. So see here, also there are the path of that ay to ax. then ay is here, this is our a, so it is represented as a y, this much value is ax, then after also by, then after we will the bx, and also cy and cx. So this is our values, are path length are there, but this is our vectors quantity are there, so b bx, and we will get b our a vectors, b vectors, and also c vectors are there. So due to this phenomena we will get that the vector component of this phenomena. See, this is our graphical method of additions. Now unit vectors in a rectangular coordinate. So there are the unit vectors of rectangular coordinate. It means, see, there are the I, K, it is represented in the I, J and K cap. So in the x-axis one value, z-axis one, y-axis as represent as a j value of j, and the z-axis represent in the k K cap. So this is our graphical rotations. Sorry, this is our rectangular coordinates are there, and it is represent as a, sorry, it is represent as a unit vector. This is our unit vector. So it is represent as a I cap, J cap, and K cap. So see here, if we applying at this point on the time, we will applying the ay j cap. Our a vector is where it is situated, ay j cap plus az k cap, and also ax I cap. It is represented as a vector component and a rectangular coordinate. This is represented as a look like this. So we will get that the value of vector with the rectangular unit vector is 8 is equals to ax I cap plus ay j cap plus az k cap. So and b it is equals to also bx I cap plus by j cap and bz k cap. Okay, after that we will discussing about that the dot product, cross product, and that the velocity. Okay, so thank you guys, thank you so much. If any kind of problems, if any kind of doubt in these lectures, then comment in the comment box. Thank you guys, thank you so much.